Rational root theorem. This is going to be a continuation of what we've been working on. We're still going to be using synthetic division. We are going to learn how to factor ones that are not as easily done by grouping. So we can factor things that start with a power of 5. We can factor things that go further. We're going to stay with ones that probably can be done with grouping to begin with, just because they'll be easier beginning problems. So you're going to be a coefficient or a power of 3 on most of these as the highest. And so let's take this first problem. And what the rational root theorem is it helps us figure out what are possible roots. And so we're going to start with just finding the possible roots. And so we have f of x is equal to 2x cubed plus 6x squared minus 43x plus 21. And we're going to split this over 2 days. Today I'm just going to help you get possible ones, and then we're going to look at factoring some basic. Tomorrow we're going to actually figure out how to determine what are the possibility of roots, and have a little bit easier at the beginning figuring out where to go from here. And so step 1 on these problems is you're going to need to find all the possible factors, all the things that can multiply to create your last term. So we're going to do factors of 21. So 1 can divide into it, both a positive 1 and a negative 1. Can 2 divide into 21? Can 3? Can 4? 5? 6? 7? 8? 9? 10? 11, 12, 13. Next one's going to be 21, you think? If you don't know, you go through each one like I just did. So you do the factors of your last term. You're also going to do the factors of your first term. So the factors of your leading coefficient. So you find the x, the highest power, that's your leading coefficient. So the factors of 2. What numbers can divide into 2? Uno and dos, or 1 and 2. Okay, so now that we have those two sets of factors, the next step is to actually identify your possible rational roots. And this is the step that gets a little bit tedious. You have to list all the possible combinations where you have what I have in yellow, the factors of your constant divided by all the things that you have for your coefficient, your leading coefficient factors. And so what I do is I do them one at a time. So I'm going to take this first factor of 2. And so what is 1 divided by 1?
1.
And so you're going to put a plus or minus in front of it. What is 3 divided by 1?
3.
What is 7 divided by 1?
7.
What is 21 divided by 1? 21. Now we're going to do the same thing, but we're going to divide by 2. So, and each of these are going to have a plus or minus in front of it because If we multiply two negatives, we get the same result as if we multiply two positives to get that 21. And so let's take the 2. We're going to do the same thing. We're going to do plus or minus in the front. 1 divided by 2. So I'm taking the first one, dividing it by 2. Then I have plus or minus 3 divided by 2. Plus or minus 7 divided by 2. And plus or minus 21 divided by 2. So that's a list of my possible rational roots. These are items that if I plugged into that equation, one of these, if not more of these, are going to give me a 0. That means it's going to be a factor. There's 2 ways to determine if something is a factor. You can use synthetic division, and if your remainder is 0, it's a factor. Or if I plug in that number into your x's using your calculator, and it comes out with a 0, that means it's a factor. Which would y'all rather do, synthetic division or use your calculator? Calculator. If you want to do synthetic division, you can go ahead and do synthetic division. It's okay either way. And so we are going to go through and try several of these. And so I am going to give several of you different numbers. And we're just going to come back together as a class and come up with the answer. And I'll show you, let me do one together with y'all. Let me do 21. So f of 21. That means I want to do 2 times 21 cubed plus 6 times 21 squared minus 43 times 21 plus 21. So if you type this in your calculator, you should have come up with 20,286. Now, don't delete your calculator. You can actually go back up to that line and just change all the numbers. Click on your problem that you typed in, press enter, and then you can add parentheses and put negatives in front of all those 21s. And that way you can do the positive and the negative without actually retyping and doing another problem. So always do your positive and negative together in order to save you on time on typing these in. And so if you use that negative, you end up with negative 14,952. So neither one of those end up being 0. Negative 1.
Negative 51.
What'd y'all get for 3? Negative 3?
0.
So it seems like these two are our factors, and we're going to find out here in a second by using, we'll go back and we have to use synthetic division on these. And then 7?
700.
And technically, if y'all were doing this all on yourself, once you got that 1 0, you would stop. Okay? But since y'all did all the work, we're going to go ahead and get all the results. And we're going to show you what else it shows you. Okay, so 1/2. What did you get for positive 1/2? 5 fourths. Negative 1/2.
175 over 4.
For 3/2.
We got negative 93 over 4.
93 over 4. Negative. And then for negative 3/2.
Negative 147 over 4.
For 7/2.
119 over 4.
And did anybody go back and do that 21 halves? Okay, we're not going to worry about it. Okay, so we're going to take one of the ones that we knew worked. So let's take the positive 3. That is one of our rational roots. And we are going to use synthetic division. So synthetic division means I need to have my exponents all in order, and they were in this problem. And just so you can remember, f of x was equal to 2x cubed plus 6x squared minus 43x plus 21. So we have a 2, 6, negative 43, and 21. On 6 problems tonight, you're going to have to go further than just listing all your rational roots. On listing all your rational roots, it would stop at that first step. On the last 6 questions, you're actually going to have to go through all of the steps. And so I'm going to show you what you would do in the last 6 here. So you'll drop your first 2. Then you're going to multiply by 3. What number is that? 6. And then we're going to add 12. Then you're going to multiply. That gives you 36. Add. And that gives you multiply. And that gives you negative 21. And then add is 0. So that shows you that it worked. So one of my answers is at 3. The other one, we have to factor or use quadratic formula for 2x squared plus 12x minus 7. And so if you went further and saw that the negative 3 worked as well, you can do synthetic division again. Or if you didn't know what worked, we had f of f of x 2x squared. What was the middle one? Okay. So we can look and see if we can figure out what we can factor here. If not, we can use quadratic formula. A equals 2. B equals 12. C equals negative 7. And then do your b squared minus 4ac. So 12 squared minus 4 times 2 times negative 7. What number is that? That's the number that will go into our square root. And so we're going to do the quadratic formula. X equals negative b plus or minus the square root of 200 divided by 2 times my a. Can we take the square root of 200 and come up with a perfect number? Okay, so that means we have to figure out what sets can come out. So I'm going to take that 200, and I'm looking to see what can divide into it. 2 will, leaving us 100. Can I take the square root of 100? Yes. Doing 10 and 10. So I know a set of 10s can come out. So negative 12 plus or minus 10 on the square root of 2 divided by 4. Can anything reduce out of all of those? Yeah. We can divide all of those by 2, giving us negative 6, 5, and 2. So negative 6 plus or minus 5 square roots of 2 divided by 2. So, our rational roots, our answers for our rational roots are that first one we had, which was 3, comma, -6 plus 5 square roots of 2 over 2, -6 minus 5 square roots of 2 divided by 2. And probably what happened on the other one, at the -3, is it was if you would have done synthetic division, you would have ended up with a remainder of non-zero. And these are your factors. Like I said, only on 6 problems are you going to have to go this far. The other problems, you will stop at this step. So if I ask you for the possible rational roots, you would stop at this step. Okay? For the last 6 questions, you're going to go further.